So just to point out a couple things we've already talked about, the windows. Again, we have 500 square feet of glass on this side of this is a south facing, this is southwest facing, which is actually very intentional because dinner time, evening, when the sun is going down, we get really great light on the southwest facing glass. And on the northeast side of the other side of the kitchen is really great because we get morning light coming into the kitchen from that side by just turning the building that 45 degrees. But really the idea of passive solar is something that we thought a lot about with this project. So we're trying to capture all that winter light, but you'll notice on this side of the building it obviously becomes a lot more animated and playful. The deep overhangs up high on this level, the trellis, all those things are what they're doing is they're keeping the high sun out of the glass in the summertime and allowing the winter light to penetrate deep into the building. So the sun trellis is something that we were really excited about as well because with the large deck, it's about 1,100 square feet of deck. It goes all the way around the building. Eventually that'll be a screen porch at the end. But the trellis really created a nice little kind of intimate seating area. Feels protected, kind of a really cool spot in the summertime. So we want to introduce some planters as well. The street's called Deer Haven. That's not by chance. I mean, this is like a deer corridor from Cascade down to the river. So we oftentimes see 20 or 30 deer at a time coming through. So we're trying to keep the plantings similar so we don't just have a buffet for them. We've thought about doing, herbs, but that has not worked. So, but having these elements kind of introduce kind of a soft vegetative layer to the deck, which is really nice in the summertime. You'll also notice that the building has, we don't have any downspouts, right? So you have these big overhangs and then the gutter actually just ends. And so you'll see a stone area in the ground. That's actually, we have a scupper and it basically waterfalls out of the end. And then it goes into a retention element underneath the stones, and then it drains out into the woods. Okay, so the whole lot is gently pitched from that corner down to this corner, and you can actually kind of feel it. So that's why the deck actually steps down with the topography, and inside we have the 2 steps that go down as well. We didn't want the house to be too tall off the ground, so we actually brought it down to be closer to the ground plane. But all the surface drainage can go this way. And then above this flat roof is a green roof on this flat part. So it's just sedums, simple grasses, not too complicated, but that green roof, before we put it up there, it was like a rushing torrent of water would come down the downspouts, and now we get almost no runoff because of the green roof. We can put some up there, that's right. That's right. So you can see on this wood wall here, we really wanted to use the cedar on the exterior. We used it in some places on the inside as well, but we're really trying to introduce a human scale to the building. It felt kind of tall and imposing, but by having this sort of band of cedar along the deck, it's really where we occupy space. It feels very warm, very comfortable. And we kept the kind of gray siding, which is more standard, kind of up and high and away. It's flat. Well, I mean, it pitches. It's like a flat roof on a typical commercial building. There's 2 roof drains. You can actually see how the wall here, this whole center wall between the doors, actually pops out about 4 inches. And same with the wall right here at the end of the planter. Those actually come out because there's a downspout drain in each one that comes off the roof. I didn't want a pipe sort of right where we're spending all of our time, so the wall comes out to hide the pipe, and it goes under the deck and all the way around to the woods. So we talked about the passive solar component, which basically relates to the overhangs and the relationship of the overhangs to the glass. But the active solar, you can see it on top of the upper level roof. So that's a due south facing roof. And we have a 5 kilowatt system up there, so it produces a little over 6,000 kilowatt hours of energy per year. So a kilowatt hour is like running a 100-watt light bulb for 10 hours. That would be 1 kilowatt. So we produce about 6,300 kilowatt hours per year. The house consumes about double that. So we offset about half of the cost. And then underneath the ground, we have the geothermal horizontal ground loop. We have a 3-ton heating and cooling system in the house. And what's really great is because of the deep overhangs and the air sealing in the building, our entire cost for everything, because we only have an electric bill, for 4 months of last summer, from May, June, July, and August, was only $178. So that included cooling, washing, drying, lighting, everything. We don't really have to use any lights in the house during the day. And in the summertime, when it's light till so late in the evening, we find that we don't really have to turn on the lights except for maybe an hour before going to bed. So again, trying to kind of strengthen the lifestyle that we already are wanting to live. So as we enter into the mechanical room, you'll see there's a 3-ton geo to air system. And so this system has the lines running out into the yard. So there's a pump that pushes the fluid through the horizontal ground loop. And that air then comes into, that water then comes into the mechanical space and gets distributed over an air coil and then pushed through the house. We do have a desuperheater on the geothermal unit, and that hot water gets dumped into the domestic tanks. So we're able to use that hot water for our domestic. And then the domestic hot water is being heated using the heat pump hot water heater. So what you have on the top is a condenser, and it basically is pulling the warm air out of the room in this mechanical space and then heating the water with it. From there, we're actually borrowing hot water from this tank, and we're transferring it over to the heat plate exchanger, which is on the other side of the room here, and that is circulating the hot water through the floor, the radiant slab, which is a 600-foot radiant slab, 600 square foot radiant slab in the kitchen, mudroom areas. And so what we did learn was that the demand on the hot water heater for basically just domestic use, taking showers, laundry, was a little bit too high. So we had to add a second storage tank because we needed that extra 40 gallons to support the usage that we needed for the house. Down the corridor, we have an ERV system. It has two 8-inch ducts that run to the exterior of the building. They're separated by 10 feet on the outside elevation, and we are bringing in fresh air into the system, introducing it to the forced air and distributing it through the house. And then with the other side, we're disposing of the stale air in the house. So this is how we exchange the air in the building mechanically. So this project is it's LEED Platinum pending. So we achieved most of the goals during construction with waste and the methods and the different configurations that we were needing to do to achieve the points. But there were some lingering requirements that we had to wait for the spring to do. So the landscaping, which is now in place, the rain garden, the drainage, were all important pieces, and the green roof as well, which are now in fact completed. So we should be ready to get the final checklist approved for the LEED Platinum. And the project was projected to be to have a HERS rating of 38, and we were talking about, recently we've been talking about what the projected design numbers were going to be for the house versus the actual, now that we've been here for a little over a year. And I can say that the projected energy costs outside of the recent increases in electricity rates, have been not quite as high as I had predicted initially, but they're certainly still substantial. So, we saved about $1,000, $1,060 last year in electric costs because of the solar. That's the 5 kilowatt solar array on the roof. And we had projected initially that that would cover about 60% of the energy usage of the house. In fact, it covers a little less than 50%, probably 45, 50%. So not quite as good as what we were hoping for, but certainly it makes a big impact on our utility ongoing cost. So it's a 5 kilowatt system. It produces about 6,300 kilowatt hours of electricity per year. And we were initially projecting about a 9,000 kilowatt hour consumption for the house itself, including all of the features, the windows, the assemblies. And in fact, we're closer to 12 or 13, so 1,000 kilowatt hours. So we are higher than we anticipated. But going through a full year now, what we've learned is that we need to adjust some lifestyle elements, using more natural ventilation. I think we could reduce our summer energy costs quite a bit, actually, by using more natural ventilation and less air conditioning. So those were things that we weren't really paying as much attention to last year, and I think this year we're going to be focusing on that much more. So I think our total project consumption will actually go down in 2018 by just adjusting some things in our lifestyle that we learned about last year. There have been some questions about some design decisions that were made and how they affected or I guess how they benefited or adversely affected the energy consumption. And I would say that we're very happy with the envelope of the house and the southern orientation of glass and the window choice that we made and the solar array. But there are some spatial configurations in the house that work against us. And I think probably the primary item on that list would be the kids' bedrooms. They have a large north-facing wall, and they're very tall. So the footprint is small. It's only 10 by 12. But because they have 15-foot ceilings on the high side, we end up using more heat than we'd like to on that upper level, and a lot of that heat just stays high in the room. And so the heat ends up having to run longer to make it comfortable down at the sleeping level. So some of those things, we were trying to get high northern light, but in fact, it's driving the energy cost for that portion of the house. So we're thinking of installing ceiling fans on those to keep the air mixed in those rooms. That was something we had not anticipated originally, but I think by adding a simple ceiling fan, we can actually reduce the overall energy consumption by quite a bit for the upper level.
Well, thanks for joining us, and a big thanks to our volunteers, our board of directors, our members, and our sponsors who allow us to do what we do. A huge thanks to our top sponsors, T-Stud, who make insulated studs that help save energy and money in the walls, and Shrinergy, who have microgrid solutions and portable battery and solar solutions for emergency issues, for travel, and for backup energy and saving energy at home. Check them out. And make sure to go to our website, greenhomeinstitute.org. Again, check out all of our videos and upcoming session and live webinar events. Thank you.